so let's look at this problem. Ammonia, NH3, is a trigonal pyramidal molecule with H and H bond angles of about 107. And so we want to describe those bonds and their hybridization and that angle. So to be able to talk about the hybridization, if I want to know the hybridization, I have to understand what it is. What is its structure? So it tells me, I don't actually have to draw it because it told me what the geometry was. It told me that it had a trigonal pyramidal geometry. So trigonal pyramidal is the subgroup of what parent geometry? The parent geometry is tetrahedral and falls under this geometry, which has how many electron groups? 4 electron groups. Another thing that helps me is because if this is a subgroup of tetrahedral, I know the bond angle is less than 109.5, and it told me it's 107. So that kind of helps me confirm I'm right. So it kind of gives you a check on your number of electron groups. So if I'm trying to figure out the electron, the hybridization, it's 4 electron groups. So that means I have one S, a P, and a P, because I have to have 4 different orbitals. So when I smush all that together, I get an sp3. So now I have an sp3 orbital. That's what the orbitals are going to be on my NH3. So each one of these bonds is an sp3 orbital that have this bond angle of 107. So if we were to go back, it would look like this, okay, sp3. And so, but because it's a subgroup, this is actually lone pairs, so it looks like this guy. And each one of these is an sp3 orbital on each of one of those NH bonds. Okay? So all you would have to answer is, what is the hybridization? sp3. All right? Now, another thing that we need to talk about when we talk about hybridization is the type of bonds that we're forming. So when we're making a bond, we can make a single bond or we can make a double bond. So the type of bond that we're forming is going to also change our hybridization. So that's what we're going to talk about in the next lecture.